Hey y'all. Today's objective is the greatest common factor, and we're specifically going to be talking about monomial common factors. So you've done greatest common factor with numerals, so now we're going to add in variables, and we're going to talk about monomials. So a monomial is a combination of numbers and variables together, and if you have a string of monomials, maybe you have a binomial, a trinomial, a polynomial, so it would be multiple monomials together. So we are going to take two or more monomials, and you have to find the greatest common factor. Just a quick review. To find the greatest common factor, you want to use the prime factorization. So we're talking about prime numbers. Prime numbers have only two factors, one and itself. So a number like 5 is a prime number. A number like 6 is not, because to get 6, you can do 1 times 6 and 2 times 3. You're going to use integers and variables, and if you're talking about specifically variables, this is supposed to say variables. Sorry. The greatest common factor of variables is going to be the variable with the smallest exponent. So if you have, I'm going to show you what that looks like. But if you have variables, you're going to have to take the one with the smallest exponent. It's going to be the greatest common factor. But I'm going to show you how to do these examples. All right, example 1 says find the greatest common factor of the monomials. Sorry, pull that off. Find the greatest common factor of the monomials. So in example A, we have two monomials, 10c d squared and 25c cubed d squared. These are two monomials, and we need to find the greatest common factor. We're going to do the prime factorization. So for the value of 10, that is 2 times 5. Those are both prime factors. And then for c, that's like an exponent of 1. So we have c. And d squared means we have two d's. D times d is d squared. So this is 2 times 5. And if you want, you can do multiplication dots, but I usually just do them between the numbers so it doesn't look like 25, and then I just write the letters. Now 25's prime factorization is 5 times 5. 5 times 5 is 25, and then we have c to the third power, so that means 3 c's, and d squared would be 2 d's. So step 1 is you're going to write the prime factorization. Step 2 is we're going to identify the common factors. A factor is a number or value that will divide into the monomial evenly. No remainders, just a whole number. So they both have a 5 in common. And they both have a c. Now this has extra c's, but this one only has one c. And they both have 2 d's. Now, when I said the smallest for variables, the smallest exponent, this is what I mean. This term up here has 1c, c to the first. This term right here has 3 c's. But we want to use the smallest exponents. We're going to use c to the first power because they both have 1 in common. You can't say c to the third because this term up here only has 1c. Now we're going to combine all this, and so we have 5cdd. And our greatest common factor is 5cd to the second, because I have two d's. D times d is d squared. So here's our greatest common factor. Let's do example B together. I need to start with writing the prime factorization. So for my first term, 4x to the fourth times y would be 2 times 2, x, y. 4 x's. And remember, this is y to the first. My next term is 8. So 8 is 4 times 2, and 4 is 2 times 2. So the prime factorization for 8 is 2 times 2 times 2, 3 x's, and 2 y's. Now I have the prime factorization of each term, so I can find the greatest common factor. I'm going to circle what they have in common. And they have 2 2's in common. Looks like they have 3 x's and then 1 y. So for the greatest common factor, 2 times 2, 3 x's, and 1 y. Again, the smallest exponent, so between 4 and 3, the smallest exponent is 3. And between the y exponents, the smallest exponent is 1. So I'm going to write all that together. The greatest common factor is 4x to the third times y. That is the greatest common factor of these two monomials is 4x cubed to the y. 4x cubed times y. So 2 more examples. Example C, I have 3 terms. 3 terms, so we need to find the greatest common factor of 3 terms. You're going to do the same thing. We're going to write the prime factorization. The prime factorization of 4x squared is 2 times 2, and then 3 x's. The prime factorization of 2x squared is 2, and then 2 x's. The prime factorization of 6x is 2 times 3, and then 1x. Once you write the prime factorization, you can find what they have in common. They all have a 2 in common, and they all have an x in common. Again, the smallest exponent, so we have an exponent of 1, exponent of 2, exponent of 3, and then 2. So my greatest common factor is just 2x. 2 times x is 2x. You try D. Pause it. You try D. Press play when you're ready to see the answer. Now, the order doesn't really matter. You could write 3 times 3 times 2, and that's the same thing. I just write them in order from least to greatest. They have 2 3's in common and a y. So the greatest common factor would be 9y. So I hope you got 9y. If you did, great. And you're catching on to the greatest common factor of monomials. Now, example 2 is going to focus on what to do when we have a negative. So example 2, find the GCF. We're going to do the same thing with a prime factorization, except if it's a negative term, we're going to start the prime factorization with a negative 1. So example A, I have negative 4a squared times b, negative 8ab squared, and 2ab. So I'm going to write the prime factorization of each, but because of the negative, I'm going to start with negative 1, and then you're going to say normal, negative 1 times 2 times 2, AAB. For negative 8, I'm going to start with the negative 1 times 2 times 2 times 2, ABB, and then 2AB is just normal. We're going to circle what we have in common. If they all had a negative 1, we would circle it, but they don't all have a negative 1. They all have a 2, they all have an A, and they all have a B. So my greatest common factor is 2AB, which happens to be one of the terms, and that's fine. That is the greatest common factor of these monomials, is 2AB. So example B, 15w squared and negative 3wx squared. Again, we're going to start with a prime factorization, 3 times 5, 2 w's because it's w squared, and then negative 1 times 3wx. When we look at it, we see they have a 3 in common, and they have a w in common. So my greatest common factor is 3w. But if you have a term with a negative, then just start with a negative 1. Start your prime factorization with a negative 1. Oops. All right. So some more problems, 4 more problems for you. If you're feeling like you got it, then pause it now and work them and then check. Or you can wait until the last one as a you try. So I'm going to work these through with you. The prime factorization of 15 is 3 times 5 times x. 25, we've already done that one. 2 x's. And the greatest common factor is 5x. The greatest common factor is 5x. All right, B, we have 3 terms, and then you have a negative right here. So don't forget to start with your -1. For 12xy, that is 2 times 2 times 3xy. 24 is 2 times 2 times 2 times 3xy. Now, if you're not sure how I'm getting 2 times 2 times 2 times 3, then you probably need to go back and review greatest common factor, because that was definitely not an 8th grade skill. And then -30 is going to start with -1 and times 2 times 3 times 5. 2 times 3 times 5. Again, the order doesn't have to be necessarily in that order. 2 x's and 4 y's. Now, the more you practice prime factorization, the better you'll get. And in this, you circle the ones you have in common. So the greatest common factor, they all have a 2, they all have a 3, all have an x, and then they all have a y. So 6xy is the greatest common factor, 6xy. All right, letter C. You have 3 terms down here. Prime factorization of 12 is 2 times 2 times 3jk, 2 times 3jjk, and 2jjkk. That sounds funny. When you write the prime factorization and you circle what they have in common, they all have a 2, and then they all have 1j. So 2j. Oh, and they have a k. And they all have a k. So 2jk would be the prime factorization. Okay, letter D. You can pause it and try it on your own. But if you have done this one, you've listed out the prime factorization, then you will notice that G is the only common factor that these 2 terms have. They don't have, besides 1, but we don't write 1G. So 10 and 7 don't have any common factors besides 1, and you have to use the lowest exponent, so G is the only one. All right, we're going to practice more of this in class.